Now that you have already seen what CsensorNet is all about, let us dive deeper and understand its building blocks. In this video, I will primarily focus on explaining to you the CsensorNet architecture, its various components, and how they integrate with each other. CsensorNet can primarily be divided into the following components. 1. Device management. 2. Edge computing and gateway. 3. Messaging infrastructure. 4. Data management and analytics. And 5. Enterprise tools and analytics. Let me try to explain each of these in a bit more detail. Device management. This component serves as the starting point for any CsensorNet-based solution, be it a smart home solution, smart farm, an irrigation solution, or a smart fleet management solution. Everything would start from device management. Device management is responsible for configuring different sensors that are required for a solution implementation. How do we get the data from the sensors? Every sensor transmits data through an industry-standardized mechanism called protocol. CsensorNet also supports a variety of protocols which govern the communication or data exchange for the sensors. Protocols like TCP, RFID, BLE or Bluetooth, Modbus, Narrowband are supported by CsensorNet already. In the upcoming release, we are planning to support protocols like LoRa, also known as long range, followed by Wi-Fi and 5G eventually. This will enable us to communicate with the devices which are at a large distance. Edge computing and gateway. This acts as a central point connecting various devices and sensors. Device Hub enables devices to send the data further down the line. Although any CPU with I/O channels can be used to perform the role of an edge device. However, in production deployments, there are custom-built devices which should be used. Fanless architecture devices are genuinely used as device hubs. At this point, we have captured data from the devices. We still lack the mechanism to send the data to the backend, so that's where we can derive meaning out of it. CsensorNet's messaging infrastructure component is the solution to this problem. It works on the publish, subscribe, also known as pub/sub principle. In simple terms, it means to get the data from someone who produces the data and give it to someone who needs it. It is the messaging system which is capable of handling high volumes of data. The features which make an obvious choice for IoT are scalability. It provides a four-dimensional scalability like event producer, processor, consumer, and connector scalability. In simple terms, it scales without downtime. Fault tolerance. It can easily handle failures without any data loss or downtime. Performance. It supports high throughput of publishing and subscribing messages. There needs to be someone at the other end of the message broker/queue who would store that data. Data management component of CsensorNet plays this role. It has been designed in such a way so that it can handle large amounts of unstructured data. It is built on an open source technology, supports elastic scalability, and gives high performance. Data management component can easily be scaled up or scaled down without disturbing the structure, which effectively means zero downtime. It supports replication, which translates into guaranteed response. The data that we have captured would not make any sense unless we could derive an actionable and meaningful conclusion from it. How do we do that? Enterprise tools and analytics is the answer. This component of CsensorNet helps to give an in-depth insight of data. Whether you want to see the data as a pie chart, line chart, bar graph, or you intend to export your data to a third-party system or to your own downstream systems, the choice is yours. It gives you the option to monitor live data or historical data. I think now is the right time to practically see how all these components come together and create what we know as CsensorNet. We have lined up a few demos for you. Enjoy!